Welcome to a video on how we solve inequalities, both for polynomial functions and rational functions. So earlier in this unit we talked about how we could graph a polynomial using things like x-intercepts and the multiplicities that go with them and the end behavior. We can match all of that up. So this sort of problem here where I give you this sort of equation and say get this graph, that should be kind of review. So if you need to pause the video and kind of figure out why that function looks like this graph, please do so. We're just going to assume that we're okay with that graph. And then so far that's all we've done, but we could say things like where does this function, where is it greater than 0 or where is it less than 0? And so just a quick little review, what do we mean by that? If we're going to say in that first arrow there, where is the function greater than 0, we're looking for where the graph is above the x-axis. And so we're looking for the x values where that occurs. And if we were to say where is f of x less than 0, well then we're saying where is it below the x-axis. Okay, so we're going to use this graph just to kind of model some of that, and we might infer a few things from the equation itself. But in example 1, they say find the values of x where the entire equation is greater than 0. We would look at that equation and we'd say, well, it's greater than 0 when we kind of start looking at it. So at the x value, or at the idea of negative infinity. Okay, and then it looks like at 3 is kind of where or at negative 3, excuse me, that's where it stops. So going through negative 3. And then way far on the right side, it seems to again go above the x-axis. So that is at 5 going to infinity. Part B, the only difference is now they're saying it could also include 0. So a lot of our numbers are going to be kind of the same. We're still going to start at negative infinity and we're going to go to negative 3, but now I put a square bracket there because we could include the idea of negative 3. Okay, and then I also need to be a little careful here because that value of x equals 2, technically it does equal 0 there, so I need to use these kind of funny brackets. That was not so good there. There's a better one. But we're going to include 2, and then we're going to start again at 5, but we're including 5 going all the way to infinity. Okay, and then C and D are just kind of the opposite, but now we're looking for where things are less than 0 or less than or equal to 0. So for the less than 0 part, we're going to start at negative 3, an x value of negative 3. We're going all the way to 2, but we would not include the 2. We pick up again on the other side of 2 and go all the way to 5. We're not including any of those values. And then for the last part, find the x values where it's less than or equal to 0. Then we want to include that negative 3. We're also going to include the entire stretch, like 2 is part of that now. It's equals 0 at 2. So I'm going to include all of that. I'm going to go all the way to 5 and include the 5. So there's a variety of things that we could answer with that equation. So if we look at some other examples, what happens if we don't want to have to make a picture, a graph of it? What if we just want to look at the equation and have another method of doing that? So a sign chart is something that could be helpful for that. So in example 2, I'm going to show you what that sign chart might look like, and then we're going to kind of use that to answer example 3. So for a sign chart, typically you're just going to make a number line. This, in some ways, this represents the x-axis. Okay, and if I look at the equation there, if I think about where this would equal 0, it's going to happen at 1 and at 7, and then that last chunk's a little tricky, but it's going to happen at negative 5/3. So I'm going to have negative 5/3 as an x-intercept. I'm going to have 1, and then I'm going to have 7. So I'm trying to do this sort of in numerical order, just as it would appear on a number line. And then for what we're going to do down the road, it might be helpful just to say these are all zeros or x-intercepts, because for what we're going to do later on in this lesson, there might be other things that we would mark on here, but maybe we just want to know that those are all zeros or x-intercepts. Then basically we're just going to say let's try to plug a number somewhere in between these intervals, some x value, into the function and just think about what kind of signs we would get from each part. So one nice thing to pick in between this area right there would just be to pick the value of 0. That's always a nice one to put in there. And what we're going to do is we're going to plug a 0 in for the x's in each of those three parts and just think about what's the output going to be there. So if I were to plug in a 0 into the x minus 1 part and then I square it, that's always going to be positive. So my first chunk of this polynomial has to be positive when I plug a 0 in. I could have picked anything in between -5/3 and 1 and I would still have that be positive. It just 0 is a nice number to work with. If I plug it into the second chunk, the x minus 7, a 0 minus 7 gets me something that's negative. And then if I plug a 0 into the last part, into the 3x plus 5, in the end I'd get something that's positive. Okay, so I need to go through and I need to think, what is that kind of telling me about an overall sign? So if I did a positive times a negative times a positive, overall this whole chunk would be negative. So on my graph, I know that part's going to be below the x-axis. Now, at that point, I could use some of my ideas of multiplicities and realize, certain things are going to happen. So the multiplicity at -5/3, because that's kind of what I'm looking at here on the number line, this is a multiplicity of 1. So I know it has to go through that x-intercept. So I can just kind of say, well, I know over here it's going to be positive. Now we could check that, and we'll probably do that for at least one of them. But that's something that we know already. The multiplicity that goes with the 1, let me get my highlighter here, so right here, this multiplicity right there, that's even. So at this x-intercept, it's just going to touch, but it's not going to actually fully switch. So I know that it's going to stay negative over here. And then the multiplicity at the x-intercept of 7 is 1 again, so it's going to go through, so this would be positive. Now we could certainly just go through and kind of do what I had done earlier. So if we just look at the multiplicity way on the right, or I'm sorry, not the multiplicity, the overall sign way on the right side, so something in this area, we could look at that and say, well, let's try to plug an 8 in, because an 8 would represent every number that's over on that side. So if I were to plug an 8 into the first chunk, so 8 minus 1, and then I square it, that part is positive. If I plug an 8 into the middle part, 8 minus 7 would be positive, and the last chunk would also be positive. So a positive times a positive times a positive gives me positive. I could have done that with all 4 chunks. All I'm doing is, as a shortcut, we could use the multiplicity idea to get some of the other ideas. So in example 3 then, they're asking, where is this same function going to be greater than 0? That means where is it positive? So based on our sign chart, I look for where it's positive. And I would say, well, from negative infinity all the way to -5/3 is where it's positive. I'm not going to include the -5/3 because that's where it's 0, and that's not part of this question. But then it's going to pick up again way on the right side at 7 and go all the way to infinity. So I think that's a good stopping point for us right now. And we'll kind of pick this up with rational functions in our next lesson.